So arrays are cool and all, right? But there's a few things that kind of make it annoying sometimes. Let's say I wanted to add a completely new element to my array that changes the size of the array, right? Do I really have to create a new array with the size of that new array being the old array size plus 1, and then copying every element from the old array into the new array at the exact same index positions that was there, and then at the end of that array putting the actual element I wanted to add, and then setting my old array equal to that? It's a lot, right? Like, I just think it would be really cool if we had one data structure that simplifies all of that process into just one simple line. Welcome back to LearnAPCSA, and in today's topic video, we're going to be covering wrapper classes and array lists. So, let's get started. Now, array lists do differ from arrays in what they hold. For example, in arrays, you can have an array full of ints. Nice and simple, right? But that doesn't quite work for array lists. You can't make an array list full of primitive data types. You can only have it of references. Think non-primitive data types, like strings. Now, how do we make array lists full of ints and doubles and chars and all of our wonderful primitive data types if Java says that we can't? We can use things called wrapper classes. Wrapper classes are kind of like the counterparts to primitive data types. What they do is they wrap a primitive data type in a object. Like if we had a string s that equals hello, s itself is just a reference pointing to hello in Java's memory. It's the same thing for wrapper classes. These are just the big boy versions of our primitive data types. For example, int's non-primitive counterpart is integer, and double's non-primitive counterpart is double, but with a capital D. But Java doesn't want to make this too complicated, right? If you wanted to make an integer into an int, then you don't need to use some sort of method or something like that. Autoboxing is the automatic conversion of a primitive data type into its wrapper class, while unboxing is the automatic conversion from a wrapper class to its primitive counterpart. So you don't need to worry about that. Java has you covered. So using these cool wrapper classes, we can actually make an array list that has ints or doubles or chars under the guise of integers or doubles or characters. So when we create an array list, it's kind of like when we create objects. We set up a data type, we set up a variable name equals new, and then whatever the constructor of that is. Now the constructor for array lists, which is array list parentheses, automatically creates an empty array list. This is different from what arrays do, where they have a data type, and when they create it, all of the values are filled up with null or 0 or 0.0 or whatever the nothing value of that data type means in Java. If you try printing an array list out right after it's created, there's nothing there. It's no null, it's no 0, it's just nothing. Now when we're creating an array list, you may see in the data type part of it that we have array lists, and then we have these weird greater than less than looking signs, right? And then inside that we have a data type. That's basically specifying what data type the array list is. So if we had an array list of strings, inside of those weird things we would have string. We would also do that for the constructor call as well. An important thing to remember with array lists when you're trying to use it is that you do have to import something into Java before using it. It's included in a certain package called Java util. So you would go import java.util.ArrayList, and then boom, you can use array lists. Now it's time to talk about the methods, probably the most important part of an array list. Starting off with size. If you do the array list reference and then .size, you'll get the length of the array list. And this is kind of how array.length would work for an array. There's also .add, which there are two types of. The first takes one parameter, and it's just the object you want to add. You will add it to the end of the array list, and the method call will return true. However, if you use the second version of it, which takes two parameters, the index you want to add it at, and then the object you want to add in that order, then it'll add that object to the index in the array list and move every object after that point in the array list down one. Then we have .get, which takes whatever index you put in the parameter and it'll return the object that we get from that index. Indexes in array lists work the same as arrays. It's just 0 to the array list size minus 1. Then we have .set, which replaces an object in the array list with another object. It has two parameters, the index we want our new object to be at and the actual object itself. This method effectively removes whatever was at that index before, but it will still return the object that it replaced. So whatever object was there before we set our new object there gets returned. .remove is kind of like add as well, where it has two versions, first of which removes whatever element of the array list is at a specific index. The one that removes at an index returns the element it removed, and the second of which removes a specific element that you want removed. The parameter it takes is that element, and it'll look through the entire array list until it finds the first instance of that element, and then it removes it. It's out of the array list. The one that returns based on the element only returns true or false. True if it found the element and it removed it, false if it didn't find the element. Just like arrays, you can traverse through array lists through the use of iteration. One thing to be wary of when you're traversing array lists is deleting elements in your for loop. For example, if you wanted to go through a for loop and only delete elements that were equal to some sort of thing that you wanted to get rid of in your array list, you have to be careful because when you delete that element, every element after it has its index shifted down one. So you could risk accidentally skipping over the very next element after the one you just removed, because the element that was directly after the one you removed just shifted to the one you removed's index. So now you might accidentally skip that one and risk not removing that. Now, I've been talking a lot, but make sure that whenever you watch these kinds of videos, don't just watch them. I know a lot of times you guys cram and you just watch videos and you're like, cool, I'm done. But please, please, please apply these concepts into your coding workspace. If you don't have anything like that, you can also use an online Java compiler. Make sure you're really digesting these concepts in order to get the best scores that you can on your APCSA exams. And with that, that's all we have to cover about array lists. And once again, once you're done with this video, if you have time, go and practice this. It really does help. Bye!